Welcome back, everyone. This particular session is about function composition and pipelining, and largely I'll cover composition via the two operators, which is forward composition and backward composition, and then there is pipeline operators, forward ones and backward ones. So let me just go to code and explain what function composition is. Uh, Function composition is creating new functions by combining existing functions. So imagine you have two functions like this: multiply by 2, which takes any number and multiplies the number by 2, and then you have add 2, which takes any number and adds 2. You can simply create your own function in a very traditional way. You can say let mult by 2 and then add 2x equals 2. You may, like I said, in a very traditional way, you can say add 2, or perhaps we are doing mult and then add, so we'll say mult 2, sorry, x, add 2. So multiply by 2, multiplied by 2, and then add 2, whatever the result is, goes to add function. This is actually function composition. This function is a composition of add 2 and multiply by 2 in this order. This, call this, and then call this. Now, why do you need function composition operators in F sharp? Is because function composition is a very frequently done thing. So instead of creating your functions like this, where you are doing all the manual job, you can say let composed F equals to this, and then this. Simple. As long as the output of one function can become the input of another function, you can compose functions like this, and the cousin of it, which is let reverse f equals to is the reverse one. It's just direction issue. There are certain issues because the way expressions are evaluated, but we will talk about that later. This is call this one, the output of this function becomes input of this function. Similarly, call this one, and the output of mult by 2 becomes the input for add 2. So let's just run both of these. Let me just shorten the names, F1, F2, and I should say F1 10 percentage A, and similarly F2, and let's see the results. So in both the cases, no surprise, you have 10, you multiply it by 2 becomes 20, you add 2, it becomes 22. Now you may wonder, what's the big issue, or you may wonder about the usability of these operators, because you may imagine multi-parameter functions, because in reality you will have quite a lot of functions which are multi-parameter. If a function is multi-parameter, what happens to this whole issue? So let me just break it down. Let me just completely change it. Let me just write down two functions: mult x y equals to x into y, and let add x y equals to x plus y. Let me get rid of this. Let me get rid of all of this. Now, remember in the last discussion we talked about partial application, and partial application was supply anything which is less than the total number of formal parameters, and you end up with another function. So if I say let mult by 2 equals to, I'm just applying x, I'm leaving y hanging, no y. And similarly I'm saying add 2 is add 2, again I'm just supplying x, I'm not supplying y. And now if I say let composed equals to mult by 2 add 2 and composed 10, the output goes to println percentage a. Now let's see what happens. Same result. What you have to notice here is that these utilities per se, the ability to partially call a function or the ability to compose functions, it's not just about solving problem a different way or writing code a different way. If you look carefully, if this is your business logic, if this is what you have already written, with these tools and techniques, you save a lot of time, you save a lot of effort, and as a matter of fact, you offer abstraction also. The composed function does not know what is going on here, what are these two functions. This was a generic implementation of multiplying two numbers. You created a specialized version of mult by 2 and add 2. The compose function is not aware of the fact. The compose function is just aware of the reality that the output of this function can go to this function as input, and that's it. So composition is creating new functions by stitching existing functions. Similarly, you have pipe operator, and it may seem as if it's the same thing, but no. Pipe operator is not about creating anything. Pipe operator is a pure convenience function. So for example, you may say can pass it to mult by 2, pass it to add 2, and pass the result to this, and you get the same result, but not the same thing is not happening. You get the same result. This and this will produce the same result, right? But in this case, you are calling a composed function. In this case, you are passing 10 to function 1. The output is then passed to function 2. The output is then passed to function 3, and so on and so forth. So composition is about, especially when mixed with partial application, composition is about, it's like Legos. You use a lot of small things to make bigger things, and you spend least time in the ceremonial code in stitching things. You just stitch things with glue with least possible effort, while pipelining is about sending. It's like an assembly line in an automobile factory. So this is your assembly line. Now pipelines don't care what are there. It can very well be a composed function here like this. So as long as output from the previous stage of pipeline can go to the next stage of pipeline, you can create any length of pipelines, and as long as functions can be chained, output of one goes into another one as input, you can create functions. And always remember, there's F#. In F# functions are a very ordinary thing. They are special, but the treatment is very ordinary. Just if you had integers, you could have done anything with those integers. Similarly, you can do anything with functions. There are two this double pipe and triple pipe operators. These are useful when you have to pipe in tuples, because tuples are heavily used in F sharp. So here's an example. That if you have, what's wrong there? What's wrong there? I perhaps need to. Oh no! I'm so sorry. I need to add a double pipe. I was wondering what's going wrong. Yeah. So you have a tuple of two values, and you have a function of two parameters. So double pipe operator can split or extract the values out, and the answer should be 3. Sorry, 2. 1 into 2 is 2, and if you just make it 5, you should get 10. Similarly, if you have a 3 value tuple and a 3 value function, you can create your own 3 value. You can use the 3 pipe operator to pass on the value. So more than 3 values or a function with more than 3 parameters is something you will not really frequently encounter, but if you have to do that, you can pretty simply do that. You can create a 4 pipe or a 5 pipe operator, which we will see when we discuss how to deal with tuples in the via pattern matching and how to overload operators and so on and so forth. But this is to give you a rough idea of what composition is. I have tried to explain it also, that as long as if you have 3 functions and the output of F, which is T2, if it is the input of G, and the output of G, which is T3, is the input of H, you can use forward composition to create more functions. Similarly, you can use backward composition, and there is pipeline operator, which we talked about, and then there is backward pipeline operator. Now, backward pipeline operator may seem similar to the forward pipeline operator, but there is a problem. So let me just highlight what I'm trying to say here. So what we are doing right now is oh no, I'm writing it the other way, so sorry. What we are saying here is pass 10 to compost. So far so good. But if you remember, we were in a position to write something like this: 10 pass to multiply 2, pass the result to add by 2. Now if you want to do the exact same thing with the reverse pipe or the backward pipe, that's not really possible. Up to this point everything is fine, no problem, but if you add this also, you will run into errors, and that's because of the nature of how statements or expressions are evaluated. Expressions are evaluated left to right, so anything which is like this is not a problem, but if things are left to right, there are problems. So you have to start adding all sorts of brackets and jazz, and this is where the usability of multi-stage pipeline, which has the reverse operator, it becomes the usability isn't really there. It becomes more taxing to add brackets and so on and so forth, versus just writing a forward pipeline in a natural manner. So beware of this issue. You will rarely encounter a long pipeline which is based on backward pipeline. You will very frequently encounter pipelines like this. F sharp code and samples are full of this. So that is it. So just go through the blog also. I've also tried to explain that don't be confused by the similarities that are there. Composition is to create functions. Pipeline is a convenience feature. You can write the code in a different way, but what is written as pipeline is exceptionally readable, easy to write, easy to read, easy to maintain. And oftentimes in reality, composition is used along with IOC and or partial application. So that's all for now. See you in the next one.